at the end of class. Today's topic is dividing polynomials by monomials. Today is the 21st. All right. So the notes here say to divide a polynomial by a monomial, divide each term by the in the numerator by the term in the denominator, and then for exponents, recall the quotient rule. So this is another situation today where every single thing that we are doing today you have done before. We're just putting it together in a new way. So instead of multiplying the numbers and adding the exponents, today we are going to be dividing the numbers and doing what with the exponents? What is the quotient rule? So we're dividing the regular numbers, and then what would we do with the exponents? So we previously, the last few days, we've multiplied the regular numbers, we've added the exponents. So we're going to subtract the exponents. Good. The quotient rule says that if you have a base value that's the same variable or same number, and these two have some exponents, let's say a and b, this ends up equaling x to the a minus b. So this is what we learned back in the previous unit, that when you divide numbers or variables with the same exponent, you subtract the exponents. Or not the same exponent, the same base value or same variable, you subtract the exponents. And so what this says is, the thing that you really need to remember today is it says to divide each term in the numerator by the term in the denominator, meaning we're going to have to take 8 and divide it by 4 and negative 36 divided by 4. Not only that, we're going to need to subtract the exponents as well. So n squared over n, we would subtract those exponents, and then n over n would subtract those exponents as well. So on this first one, and there's something you can do as well. If it makes it a little bit easier to separate this out, you can do that. You don't have to, but it is something you can do. And what it would look like is this. You'd have 8n squared over 4n minus 36n over 4n. So because that denominator works with both terms in the numerator, that means you can separate out your fraction to write the same denominator beneath each of those two terms from the numerator. And so if you want to separate it out, it might visually make things a little bit simpler for you. You can do that, but you don't have to. But if you do it this way, 8 divided by 4 gives you 2. And then n squared divided by n is just subtract the exponents, leaving you with n. 2 minus 1 is 1, so that would be n to the first power, or just n. And then negative 36 divided by 4 is negative 9, so minus 9. And the n divided by n, those would cancel each other out. So the answer is 2n minus 9. So you're welcome to break those apart and write each term on the numerator over the same denominator every single time. Or if you prefer, you can just do everything from the original fraction. And I'll show you that on number 2 here. Example 2 says negative 14x to the 12th y to the 5th plus 7x squared y squared, all divided by 7x squared y squared. So we'll start with the first term on the numerator divided by the denominator. Negative 14 divided by 7 is negative 2. X to the 12th divided by x squared, subtract the exponents. 12 minus 2 is 10, so that's x to the 10th. And then y to the 5th divided by y squared, 5 minus 2 is 3, so that's y to the 3rd power. And then what happens with the second term in the numerator divided by the denominator? Yeah, it turns into 1. Why is that, Killian? The exponents cancel out, and 7 divided by 7 is 1. Exactly. So 7 divided by 7 is 1. So plus 1. And then the exponents are all the same, so they subtract out altogether, which means they cancel out. So our answer for number 2, example 2 here, is negative 2x to the 10th, y to the 3rd, plus 1. All right. So we're going to start working through these, and my goal is to be quick with this. And I'm going to have you work on a few on your own like we normally do, but let's go ahead and take a look at number 1. So example number 1, if you think you know the answer, let me know. For number 1, you're going to take each of the terms on the numerator, divide them by the denominator. What do you have, Alicia? 2x plus 3, excellent. So the answer for number 1, 2x plus 3, because 6x divided by 3 is 2x, and 9 divided by 3 is 3. And we don't have to worry about subtracting any exponents there because we're just dividing by a regular number. How about number 2? Somebody else? Gabriella, what do you have? Yep. Exactly. 2v squared plus 1v or plus v minus 3. Again, we're just dividing by a regular number here. So 10 divided by 5 is 2, keep the v squared. 5 divided by 5 is 1, keep the v. Negative 15 divided by 5 is negative 3. All right, next one, we're dividing by a. So we're just dividing by a variable on this one, meaning that every single exponent is just going to be reduced by 1 because we're just taking away 1 from the exponent. So on number 3, we're going to get 8a squared minus 2a plus 5. So just take away one factor of a from each one of those because you're dividing by a. Make sure you can actually see that. There we go. There's number 3. All right. How about number 4? What do you think about number 4? Let's try that one. What do you see it? 5x minus 1. Good. The answer to number 4 is 5x minus 1. 40 divided by 8 is 5. X squared divided by x. Take away one of the exponents. You're left with 1 left, so x. Negative 8 divided by 8 is negative 1, and the x's cancel out, so it's just 5x minus 1. All right, number 5. Let's see about this one. I can already see that it's going to be a plus 1 on the end. Can everybody see that? The last term on this one's going to be plus 1 because 3c divided by 3c is going to be 1. And then the ones before it, 18 divided by 3 is 6. C to the 3rd divided by c, take away an exponent would be c squared, so 6c squared. Negative 21 divided by 3 would be negative 7. C squared divided by c is c. And then 3c divided by 3c is 1. So 6c squared minus 7c plus 1. How are we feeling so far about this? Pretty decent, right? Hopefully not too bad. If you can divide two numbers and you know the quotient rule, then we're good. Number 6. Any thoughts on that one? What is 6 divided by negative 2? Let's start there. Negative 3, all right. A squared divided by a is what? Just 1a, so a by itself. And then b divided by b, those would cancel. So the first term here is negative 3a. Then we're going to divide negative 12 by negative 2, which equals what? Negative 12 divided by negative 2. 6. All right, so positive 6. And then a divided by a, the a's cancel on this one. And then b squared divided by b leaves us with a b there. So we got negative 3a plus 6b for our answer on number 6. All right, I would like you to try 7, 8, 9, and 10 on your own. Take a few minutes on that. If you have questions as you're working through these, let me know. And we'll go with about let's say 3 minutes on this. So 4 problems, 3 minutes. See what you can come up with. Let me know if you have any questions. Okay. Number 7. Somebody want to volunteer an answer for number 7? Do you think they got it? That? Cough, cough. Be interesting if that's how somebody coughed. Kind of sounds like a crow. All right, anybody know number 7, or anybody think they've got number 7 here? Let me see what do you have. Good, negative 4x minus 1. So negative 20 divided by 5 is negative 4. The x squared divided by x leaves us with an x here. And then negative 5 divided by 5 is negative 1, and the x's cancel out. How about number 8? Somebody else for number 8? Killian? The negative 2x squared y squared. So 14 divided by negative 7 is negative 2. 6 minus 4 is 2. 3 minus 1 is 2. So lots of 2's there. And then negative 49 divided by negative 7 gives us the plus 7. And then 5 minus 4 means we're left with an x. And then 9 minus 1 would be y to the 8th power. All right. Now, technically speaking, we should probably go ahead and flip-flop those two terms. Why is that? Yeah, there's more exponents with the 7xy to the 8th than the negative 2x squared y squared. So we still have to consider standard form here. So I'm just going to go ahead and hop up here real quick. 7x y to the 8th minus 2x squared y squared. So that, we'll go ahead and call that our answer there, just to make sure we go in descending order of the total exponents, which would be considered standard form. All right. 2 more to go here on number 9. Let's go ahead and check these real quick. So Negative 25 divided by negative 5 is 5. 4 minus 2 gives us x squared. And then 3 minus 1 gives us y squared. And then 30 divided by negative 5 would be minus 6. And then x squared divided by x squared, the x's cancel out altogether. And then 5 minus 1 on the y's gives us y to the 4th. So 5x squared y squared minus 6y to the 4th power. That's it for number 9. And then 10, we've got 20 divided by 5, which is 4. And then we're just going to take away 1 from each of the a, b, and c's here. So a to the 6th, b squared, c. And then what's our second term on the answer for number 10? What's our second term going to be on the answer for number 10? Yeah, minus 1. Good. Negative 5 divided by 5 is negative 1. A cancels with A, B cancels with B, C cancels with C. All right. Page 2, here we go. I'm going to skip over 11 and 12. Let's look at 13 and 14. So skip 11 and 12, go to number 13. So we'll take a look at 13, we'll take a look at 14. And then let's see, we'll also skip 15 and 16. So we're just going to do 13 and 14 from this top group here. The reason why I want to focus in on 13 and 14 has to do with the exponents. Let's take a look at what happens here. So negative 24 divided by 3 is negative 8. Leave yourself a little bit of room because this is going to be 2 steps on 13 and 14. So negative 8. And then x to the 7th divided by x to the 5th, subtract the exponents, that's x squared. Nothing strange about that. However, what happens when we divide the top middle by the denominator? What happens to our exponents on this one? They're negative, yeah. So 9 divided by 3 is positive 3. 3 minus 5 is negative 2. So 3x to the negative 2 power. And then we're going to say negative 15 divided by 3 is negative 5. And then 1 minus 5 is negative 4. So that'd be x to the negative 4th power. Now, not only are we having to use the quotient rule here, we're also going to have to do what? We can't leave that as our answer. Negative exponents need to be made positive. So where do they go? On the denominator. So the x to the negative 2 is going to go underneath the 3. The x to the negative 4 is going to go underneath the negative 5. So our answer for number 13 will be negative 8x squared plus 3 over x squared minus 5 over x to the 4th. That'll be our answer there for number 13. Remember that with negative exponents, we can't have negative exponents in an expression like this and have it be in simplest form. If it was scientific notation, it would be fine. But when it's just a regular expression, we can't have a negative exponent and still be in simplest form. So try number 14. It'll end up being pretty similar. See what you can do with number 14. And then we are going to put it all together. So our first step looks like this. 3x minus 5x to the negative 1 plus x to the negative 2. Or plus 1x to the negative 2, either way. And actually having a 1 there might make it a little bit easier for you once you do the second step. So once we have that, make sure you've got that on your paper. Does anybody have an answer to this one? Let me see what you have. Good. 3x minus 5 over x plus 1 over x squared. Nice. So the x to the negative 1 has to go underneath the negative 5 as x to the first power, or just x. And then the x to the negative 2 has to go underneath the 1 as x squared, because we have to have positive exponents. Got to have positive exponents in our final answer. All right. That's it for number 14. We're skipping 15 and 16. Yeah. And then 17 through 20 is going to be basically a combination of the things we've been doing the last 4 days. So let's go ahead and check this out. Number 17, we're going to end up distributing into the 2x plus 1. But before we do that, we need to simplify the fraction. So we're going to start off by doing what we did today. So 15 divided by 3 is 5. So that'll be 5. And then x squared divided by x is x. So that's 5x. And then we've got 6x divided by 3x. 6 divided by 3 is 2. And then the x's cancel out. Now, a fraction by itself is a group. And so when we simplify this, this 5x plus 2 is still a group. But the way that we need to identify this as a group now is put that in parentheses. And then we're going to multiply that by the other one, 2x minus 1. So a fraction is a group, so keep that in mind. And so now we have a binomial times a binomial. This is what we did yesterday. This is FOIL, first, outer, inner, last. So now we've got to multiply the 5x by the 2x. So the first times the first. 5 times 2 is 10. X times x is x squared. The outer terms, 5x and negative 1. 5x times negative 1 would be minus 5x. The terms in the middle, the inner terms, 2 times 2x would be a positive 4x. And then the last terms, 2 times negative 1 would be minus 2. And then the last thing we need to do on this one is add the negative 5x and the positive 4x together. Negative 5 plus 4 is negative 1. So the answer is 10x squared minus 1x minus 2. You got 10x squared minus 1x minus 2. All right. Let's look at 18 real quick. Do we have any thoughts on number 18, where to start? Gillian? Okay, so what should we do on the top first? Yeah, we're going to distribute. And in fact, I would say let's distribute twice. We're going to distribute the 2 r to the third s to the 8, but we also have to distribute the negative. So we'll make that a negative 1, and we'll distribute that as well. So see if I can fit this in here. So let's see, I'll try to squeeze this into the right. We're going to have 2 times 7, that's 14. And then r to the third times r to the 7th, add the exponents, that'd be r to the 10th. And then s to the 8th is just going to be added to the end of that. And then we're going to multiply 2 times negative 5, which is going to be negative 10, so minus 10. And then r to the third times r to the third would be r to the 6th, because we're adding the exponents. And then s to the 8th and s to the 4th would be s to the 12th power, because we're adding those exponents. So there's our first distributive property. Then we're going to distribute a -1, which is a pretty simple thing to do. It's just the 2r to the 10th s to the 8th will be a negative, so it'll be minus 2r to the 10th s to the 8th. And then the -6 will turn into a positive, so plus 6 r to the 6th s to the 12th. And that's still going to be over that 4r squared s to the 4th. So over 4r squared s to the 4th power. All right, so step 1 is complete. We've distributed the 2r to the 3rd s to the 8th, and we've distributed the negative. All right, what's next? Once we've got that, what do we have to do next? Or what could we do next? Or should we do next? Gabrielle? Yeah, we can simplify on the numerator by combining like terms, because we have like terms. If we didn't have like terms, we'd have to start dividing by the denominator, but the 14r to the 10th s to the 8th and the -2r to the 10th s to the 8th, those are like terms. 14 minus 2 is 12. So that'll be 12 r to the 10th s to the 8th power. And we also have r to the 6th s to the 12th with our -10 and r to the 6th s to the 12th with our +6. So -10 plus 6 is -4, so -4. That would be r to the 6th s to the 12th power, all over 4r squared s to the 4th. And now this problem looks very similar to the other ones that we did this class period with our division. So we're going to use the quotient rule now. So we'll divide. 12 divided by 4 is 3. And 10 minus 2 is 8, so r to the 8th. 8 minus 4 is 4, so s to the 4th. -4 divided by 4 is -1, so -1. 6 minus 2 is r to the 4th. And 12 minus 4 is s to the 8th. And that will be our answer for number 18. So we're just doing one thing at a time. To work through these. So let's try number 19. Just got a couple more here. Number 19. Take a look at that one. What should we do first on number 19? Kelly, what do you think? By doing what? We are going to simplify, but what do we do on the numerator first? Yeah. Specifically, what method are we going to use? FOIL, yes. We are going to use FOIL on the numerator on number 19 because we have a binomial here, m squared n squared minus mn, that's a binomial. And then we have m squared n squared plus mn, which is another binomial. So we're going to use FOIL on this one just like we did yesterday. So the first times first will be the m squared n squared times the other m squared n squared. So just add the exponents. So that'll be m to the 4th, n to the 4th. The outer terms would be m squared n squared times mn. So just add the exponents again, would be plus m to the 3rd, n to the 3rd. The inner terms, the two in the middle, would be the same thing that we just did, but it's a minus because there's a negative here. So minus m to the 3rd, n to the 3rd. And then the last ones, negative mn times positive mn, that would be minus m squared, n squared, all over mn. I think the easiest way to get lost on this one is to forget where your m's and your n's are because there's just a lot of them. Okay, can we do anything on the numerator still here? What do we think? All right, what happens? Yeah, and what happens when you do that? Yeah, the positive m to the 3rd, n to the 3rd, minus the m to the 3rd, n to the 3rd, those cancel out. Those two in the middle cancel out, which is kind of convenient because that leaves us with m to the 4th, n to the 4th, minus m squared n squared over mn. And so the last part would just be to subtract the exponents with the same variables here. So 4 minus 1 is 3, 4 minus 1 is 3. So that'd be m to the third, n to the third. And then negative 1 over 1 would just be minus, or just keep the minus. And then 2 minus 1 and 2 minus 1 would just be mn. So m to the third, n to the third minus mn will be our answer for number 19. So the last one, number 20, I want you to try that one on your own. It's actually really similar to the one that we just did. Give that one a try. Take a couple minutes. We'll take a look at the answer, and then you'll have the remainder of class to work on the assignment or test or anything you need to do. So I got the first step up here. The 2 in the middle on my numerator might be reversed from what you have. And the reason why is because I knew that if I multiplied FOIL, then the O would have the 2 and the I would have the 3. So I just reversed those to put it in standard form right away. You're welcome to shuffle those around later on in the problem, but if you recognize that, hey, this term is going to have a higher exponent than that one, you can always just write that one first. So if you've got 20k to the fourth minus 12k squared plus 10k to the third minus 6k on your numerator, that's fine. Just make sure that you reorder it in order to have, just make sure that you end up reordering it in order to have in standard form. So this is what we get after our first step here. Now, there are no like terms on the numerator. So what ends up happening when we end up using our division? Do these divide evenly? No. So what should we do? Any thoughts, Killian? Yeah, fractions. That's kind of our only option there. So we're going to end up here, this first one, 20 over 6. Those can each be divided by 2, so that'd be 10 over 3. 4 minus 1 is 3, so that would be 10k to the third over 3. 10k to the third over 3 will be our first term. Now the second term, 10 does not divide by 6 evenly, but again, they're both divisible by 2. So 10 divided by 2 is 5, so this would be plus 5. And then k to the third divided by k would be k squared, so 5k squared over 3. And negative 12 divided by 6, that's divisible, so that would be minus 2. And then k squared divided by k is k, so minus 2k. And then negative 6k divided by negative 6k, that cancels out, and so it would be minus 1. Now this is one of two possible answers here. Does anybody think they know what the second possible answer might be? By the way, this is 100% correct. I would not mark you down in any way whatsoever if this was a test or a quiz. Does anybody think they know what the other answer might be, though? Gabriella? I wouldn't recommend a decimal, just because dividing by 3 doesn't give you a good decimal, it gives you a repeating decimal. It has to do with the first two terms. Killian? Put them together. What do you mean by that? Over 3, yeah. So because these both have the same denominator, in order to add fractions, you have to have a common denominator. These have a common denominator of 3. So the other option would be, I'm just going to say or, 10k to the third power plus 5k squared all over 3, and then minus 2k minus 1. So that would be your other option for an answer. Because these both have the same denominator, you can put the numerators together over the single denominator of 3. You wouldn't have to do that. This is the most concise way, I think, to write this, unless you decided to come up with, no, this would be the most concise way to do it. Never mind. I'm just going to stop there and call that what it is. Okay, so that is it. We've got about 23 minutes today to get working on our assignment. So I'm going to get this handed out. By the way, your assignment